Hey guys, so today is day number 1 of volume, so it is our new unit. So how do we calculate volume for different shapes, different figures? That is going to be our objective for today. By the end of this unit, we will go through pretty much all of these here that you see on my screen. So cylinders, cones, pyramids, cubes, spheres, triangular prisms. Today, however, we're only going to focus on these: a cylinder and a rectangular prism. So those are the ones that I want to focus on today. And again, throughout the next couple of weeks here, we'll go through and complete the rest of these. So what is volume? First of all, what is volume, since we have to talk about volume? Well, volume is the quantity of three-dimensional space enclosed by a closed surface. So again, it's basically the space inside a 3D shape. If you see here this little beaker, it is the water that fits inside. The volume is the water that fits inside. If you think of a soda can, right? If you think of a soda can, volume is that liquid that is inside. How much space is it actually holding? And now we're three-dimensional versus what we guys practiced yesterday, which was area, which is two-dimensional. Volume is three-dimensional, right? It's an enclosed shape. So what is the volume of a rectangular prism, of a cube? A rectangular prism has 3 dimensions. It has a length, it has a width, and it has a height. So it makes sense that the formula for volume, right, how much space is inside a rectangular prism, is going to be just multiplying those three things together: your length times your width times your height. So this is probably one of the ones that you're more familiar with. So again, in order to calculate the volume of a rectangular prism, you're going to multiply your length, right, times your width, right? And if you just focus on that, length times width right there, that's actually just a rectangle. That is the area of a rectangle. And then if we multiply it one more time times its height, right, you can imagine like you're creating a bunch of sheets of paper and you're stacking them, and you continue to stack them and you continue to stack them, creating this three-dimensional figure, which creates our volume. It's creating that entire space inside, right? If you keep stacking a bunch of rectangles on top of each other, you'll create a three-dimensional shape, almost like 3D printing, which is creating our volume, that space inside. Okay. And then what is the volume of a cylinder? So for volume of a rectangular prism, it's length times width times height. Cylinder has a different formula, okay? What we have to do is we have to calculate the area of the base. Okay, so you have a cylinder here. The base itself is a circle. We actually practiced that on Wednesday. So how do you calculate the area of a circle? It's pi r squared. Okay, so if we can calculate the area of the circle by using pi r squared, all we have to do next to find the volume of a cylinder is start stacking a bunch of circles on top of themselves. Stack another circle on top, stack another circle on top. So what we're doing here is we're just going to multiply by the height of that cylinder. Okay, so once you find the area, the base, you just multiply the area by the height of the cylinder to get the volume, right? Imagine you start stacking a bunch of circles on top of each other, you would create a three-dimensional shape, which is a cylinder, right? So that's where we're getting that formula from: pi r squared times the height, right? It's the area times the actual height of that cylinder. That will give us our volume. All right, so for example number 1, it says volume, calculate the volume for the following shape. So since this is a rectangular prism, I'm going to write the formula for that. It says volume for a rectangular prism, that is just going to be our length times our width times our height. Okay, so let's go ahead and fill in what we know. I'm going to go ahead and use V for volume is equal to, well, what's my length? I like to pick the longest one for length, but they're interchangeable, length and width, which is going to be 6. And we're going to multiply that by our width. Well, what's our width? Going backwards towards the back, that is going to be 3. And then what is my height from the bottom to the very top? That measures 4. Okay, all we have to do now is go through and multiply 6 times 3 times 4. Well, 6 times 3 is 18. I'll actually go ahead and do that. 6 times 3 is 18. If we multiply those two together, and then what happens when we multiply 18 times 1 more 4, we should end up with volume is equal to 72. And I'm gonna stop right there. I do want to talk about the units, because we were multiplying centimeters times centimeters times centimeters, right? Imagine if you're multiplying x times x times x. What would we get? We would get x to the third power, x cubed. So if you multiply centimeters times centimeters times centimeters, that is going to give us centimeters to the third power. So those are going to be our units, centimeters cubed. And it makes sense because we're talking about a three-dimensional shape. We want the volume, we want the space inside a three-dimensional shape. So it's to the third power. All right, let's try that one more time. Calculate volume for the following shape. So I have a rectangular prism. So volume, one more time, is going to equal then our length times our width times our height. Again, it's always just make sure you're using the correct formula for the correct shape. So I'm going to write V for volume is equal to, well, what is my length? I'm going to use my length, this one right here, which is 2.5 inches or 2.5. I would rather use the decimal. I'm going to go ahead and write that as 2.5. I'm going to multiply that by my width. My width here is 1.5 or 1.5. And then, of course, our height, which is a total of 3 inches. So we're going to multiply that by 3. So I'm going to multiply all three of these on my calculator. I'm going to go ahead and write 2.5. Let's see if I can actually take out my calculator. There we go. 2.5 times 1.5 times 3 is going to equal, that gave me 11.25. That is the volume, 11.25. What? Inches times inches times inches is going to give us inches to the third power. That is our final answer there. Volume, the space inside of this rectangular prism, is 11.25 inches cubed. All right. What about the volume of a cylinder? Find the volume of this cylinder here. I should really say cylinder. Okay, cylinder. And leave our answer in terms of pi. So they do want us to leave our answer in terms of pi, not actually multiply it out by 3.14. So what is the formula for a cylinder? Volume is equal to pi r squared. Remember, that's the formula for area. And then we just multiply it by the height. So let's go through and fill in what we can, what we know. V for volume is equal to pi. Well, I'm going to leave pi as the way it is, right? I want to leave my answer in terms of pi. Do I know my radius? Yeah, I do know my radius. From the center of that circle to the outside, that measured 25 inches. So I'm going to go ahead and put 25 to the second power. Don't forget, it's 25 squared. And then we're going to multiply that. We're going to multiply that by our height. Well, our height here is going to be 40 inches. 40 inches. Okay. So let's take this piece by piece, piece by piece. What I would do first is I would leave pi as the way it is, but I would work out this little section here. What is 25 squared? What is 25 to the second power? 25 times 25, if I do that on my calculator, that gives me 625. And we're, of course, going to multiply that by 40. So because I want to leave my answer in terms of pi, I'm not really multiplying by pi just yet. Volume is equal to pi. And what I'm going to do here is I'm going to multiply 625 times the height, which was 40. So let's multiply it by 40. I get 25,000. All right, so we have pi times 25,000. And of course, because they wanted us to leave our answer in terms of pi, I'm just going to rewrite this, right? Imagine pi was like an x. Volume here is going to be 25,000. And then we just go ahead and put pi at the very end. That is our answer right there. Volume is equal to 25,000 times pi. If they wanted us to give the decimal, we would actually just multiply 25,000 times 3.14. Let's try that one more time here for example number 4. Find the volume of, I should have said cylinder. Cylinder. Leave your answer in terms of pi. So one more time, they don't actually want us to multiply by 3.14. They just want us to leave the answer in terms of pi. So because I do have a cylinder, volume of a cylinder, what's the formula? It is pi r squared. That little section is the formula for area. We're just going to multiply that area times the height to get the actual full volume. Fill in what we know. Let's go ahead and fill in what we know. V for volume. Well, that's just equal to pi. What is my radius? From the center to the outside, that measures 3 units from the center of the circle. So we're going to write 3. Don't forget it's to the second power, and we are going to multiply that by the height. Well, the height of the cylinder, it measures 10 inches. So we're going to multiply that by 10. Okay, use a little bit of PEMDAS here. We're going to use 3 to the second power. We're going to do that little section first there. Volume is equal to pi, and that's not 3 times 2, that's 3 times 3, which is 9. And we're going to multiply that by 10. And again, because we want to leave our answer in terms of pi, I'm leaving pi here till the very end. Volume is equal to pi. What is 9 times 10? That's just 90. So we have pi times 90. If we multiply that, because I want to leave my answer in terms of pi, I would just write 90 pi. Okay, we normally write the pi at the very end, almost kind of treat it like a variable, like an x, like 90x. So there is our volume, 90 pi. And of course, this would also be inches cubed. It would be to the third power. Since we're talking about volume, we're talking about space inside a 3-dimensional shape. So inches cubed.